In this video, we're going to use slope to dilate a figure with a given scale factor. So we're going to remind ourselves how to calculate slope from a line on a graph. Looking at line A, I could count the slope between the points that are given. My rise would be positive 3, run would be positive 2, so that would be a slope of 3/2. For line B, I would have a rise of positive 1 and a run of negative 3. So that yields a slope of negative 1/3. For line C, we have a completely vertical line, and so I would rise positive 2, but I have a run value of 0. Since we would have 0 in that denominator, that gives us an undefined slope. For line D, this is completely horizontal, so I'm not rising at all. I have a 0 rise, and I'm running 3, so 0 divided by 3 gives me a slope of 0. Here we're going to practice finding slope using some points. So A is at -2, -6, B is at 1, 2, and SY has coordinate values of -2, 4, and 2, -2. You guys need to show your work in your notes. I'll give you the answers, but you guys do need to try and get those answers using midpoint formula. Right now we're going to get into what a dilation is. And here's some examples from the real world of what we would see as a dilation. A dilation is a transformation that can change the size of a figure. So like a projector screen, we have this point at which we're projecting an image out. And as we get further away, that image is going to get bigger. Just like this lamp here, as we get further away from that light, that picture is getting larger. A dilation can also be called a projection, and that's the terms in which we're going to perform our dilations, is based on that idea of a projection. So in this picture here, I'm given this triangle ABC, and I'm going to dilate this figure using my projection model. So I'm saying, well, this little dot right here, we're going to call the center of dilation. And that's the point from which I'm going to dilate. So all my dilations are going to be projected out from this point. Now I've connected rays from my center of dilation through each one of the vertices of the triangle. So from this center, I've connected that ray through A, through B, and through C. And we actually call these projection lines. So these are the lines on which all of our dilation figures are going to have vertices. So I'm going to show you a dilated figure. Notice each one of those points is on the projection lines. So our new point A, which we would call A prime, and we would denote that by A with an apostrophe. Notice the red point here is on the projection line, and we could actually use slope to find it. Counting the slope from that center of dilation, we would go up 1, 2, 3, 4, 5, 6, and to the left 2. So I've counted 6 up, 2 to the left to get to my original point A. Notice that if I count that again, 1, 2, 3, 4, 5, 6, 1, 2, then I've actually reached that A prime point. Notice that that is double the original distance from that center of dilation. So we would say this red triangle is a dilation with scale factor 2, because the sides here will be twice as big as my original triangle. What if I wanted to dilate a figure with a scale factor of 3? Well, I would count from my center of dilation that same slope that I used to get to point A 3 times. So from the center of dilation, I would go up 6, left 2, up 6, left 2, and up 6, left 2. From my center of dilation to point C. Notice it's up 1 over 1, 2, 3, 4, 5, 6. And so I would count that again. 1, 2, 3, 4, 5, 6. Up 1, and then 1, 2, 3, 4, 5, 6. Notice I'm on that projection line. This triangle would represent a dilation with a scale factor of 3. Notice that I have 3 of those sections on that projection line. That represents the scale factor in our dilation. Notice as the scale factor gets larger, our figures get further and further away from our center of dilation. We would call our original figure a dilation with scale factor 1 because it is one of those slopes or one of those distances away from our center. So what if I wanted to dilate with a scale factor of 1/2? If I wanted to dilate with a scale factor of 1/2, it would be half as far away as our original triangle. So I would count half of those distances away from my center. So if I'm going up 1 and to the right 6, I would go up 1/2 and to the right 3. If I was going up 6 and to the left 2, I would go up 3 and to the left 1. So notice this orange triangle, that represents the dilation of 1/2 scale factor. Notice how it is closer to my center of dilation than my original figure. It's actually half as close. That original distance here was over 6 up 1. Notice that's over 3 up 1/2. All right, let's actually try it with a triangle on the coordinate plane. We're going to use slope to produce a dilation of triangle ABC with a scale factor of 2. Use the origin as our center of dilation. So since the origin is going to be our center, we're going to draw those projection lines through the origin and each one of those points of our triangle. I'm going to count my slope to each one of those points. So up 3 over 2 to get to point A. If I want a scale factor of 2, I need to count that slope twice from my center of dilation. So from my center of dilation, up 3 over 2, that's once. Up 3 over 2, that's twice, and that point would be A prime. To get to C, I would go up 2 to the right 4. So from my center of dilation, I need to count that slope twice, or go twice as far. So I would go up 4 over 8. To get to B, I would go up 5 and over 3. So instead of up 5 over 3, I'm going to double that distance, so up 10 over 6. And notice I get the new triangle A prime, B prime, C prime. A prime will have the coordinates of -4, 6. Notice that's the point where my new triangle's point A ended up. B prime would have coordinates of 6, 10, and C prime would have coordinates of 8, 4. I want you to look at the original points and see how those relate to A prime, B prime, C prime. All right, here's an example using slope. I've already put our projection lines on here. Notice I want a dilation with a scale factor of 1/2, and we're going to use the origin as the center. So notice from the origin I have my projection lines. So I'm going to use those projection lines and go half of that distance. So counting to X, I would go up 8 over 2. So instead of up 8 over 2, I'm going to go up 4 over 1. For Y, that's to the left 4, down 4. So instead of 4 and 4, I'm going to go over to the left 2, down 2. For Z, I didn't go up or down, but I did move to the right 6. So I'm going to go half of that, which would be to the right 3. And notice I get my new triangle where each of those side lengths will be half as long as my original triangle. And my x prime is at 1, 4. Y prime is at -2, -2. And z prime is at 3, 0. I want you to try this example. You're going to use slope to produce a dilation of triangle LMN with a scale factor of 3 using the origin as your center, which means you'll draw your projection lines through each point of that triangle originating from the origin and dilate that with a scale factor of 3. In the last example, I want you to use slope to again produce a dilation with a scale factor of 3, except this time you're going to be using the point P at 6, 5 as your point of dilation. So plot that point P, and now that becomes your center. And so you're going to draw your projection lines from point P and dilate that figure. And that will be the last example, and we'll answer any questions in class.